the Shaheen Shahkar again, and I'm here today to talk about how do I multiply exponents. How do I multiply my bases and exponents? So we're about to figure that out, okay? So the idea is, let us say, for example, if I was looking at something like, I don't know, b squared times, let's go, a squared, b cubed, and we just discussed in a previous video what squared means, what cubed means, and we kind of talked about that. All right, and I'm also multiplying that times, I don't know, a cubed and b squared. Okay, so I'm making this up as I'm going. But anyway, the idea of solving this is I can look at this different ways. Now, if I was going to write it in expanded form does not mean me writing these problems really far apart. No, that is not expanded form. Okay, expanded form means that I'm actually writing out what is happening here. Now, how many a's do I have here? 1! Okay, so the idea is that a is multiplying times, what does b squared mean? It means it's b times b. I hope you knew that, alright? And then further on we have a squared, which means I have how many a's? I got 2 of them, so here we go. I have a times a, and then here I've got b cubed, so I'm like b, 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 alright? All 3 of those are multiplying, and over here I have a, and then I'm multiplying times b squared, b, b. So I'm multiplying all these together, all right? So we're all in this together, hand in hand, and we're going to make sure we get through it to the promised land. Here we go. So I can go ahead and see, how many a's do I have? Well, I got 1, 2, 3, 4, 5, 6. I have 6 a's, so I could end up with a to the 6th power, and then 1, 2, 3, 4, 5, 6, 7. I have 7 b's, so I've got b to the 7th power. Okay, y'all cool for that? So this would be my answer. But this is a really laborious or long way to go ahead and write this out. Laborious meaning long and boring. So, what would be a quicker way of doing this? You can totally do this. It's up to you. I mean, you're a teenager. You've got free time to do this all your life, right? So, who needs to play Call of Duty 5? You need to be like doing math problems all day long. So, anyway, moving on. How could I do this if I was going to be, if I was not going to write an expanded form? Well, I can think to myself that I can go a to the something, and it's going to be times b to the something. So the idea is that I can add up the exponents. When you're multiplying exponents, the idea, when you're multiplying these guys, what you're really doing is kind of like adding the exponents together. Now that might seem kind of crazy, but just stay with me on this one. So I think to myself, what is the exponent that is not written here? How many a's do I have here? Well, there's 1, and that's probably one of the trickiest things. It's not hard, it's just we forget it sometimes because we get super pumped about doing math and we skip over it. So careful there, slow yourself down, all right? And you're probably thinking to yourself, you slowed down. Anyway, so here we go. I've got 1, I've got 2, so I can think 1 plus 2. You understand where I'm getting those? 1, 2, and over here I got a 3. And then exponents over here, I got 2, 3, and 2. So I got 2 plus 3 plus 2. This is how I can think about it. This is how you can just process it in your mind. What I end up with is a to the 6th power, okay? Because 1 plus 2 plus 3 is 6. And times b to the 2 plus 3 plus 2, that's 7th power. And again, I'm coming to the same answer. So either way that you're doing this, you still come to the same answer. And that's what you really want to be aware of, okay? So when you are multiplying these bases and exponents, what you're really doing is you keep the same base. You good for that? You keep the same base, but you add the exponents together. Keep the same base and add the exponents together. That is the idea of what we're looking at here, okay? So, right. Division of these bad boys is kind of, it's similar to it if I'm dividing. So let's say if I was looking at x to the 6th power over x to the 3rd. Alright? So if I'm looking at x to the 6th power over x to the 3rd, I could rewrite it in expanded form. 1, 2, 3, 4, 5, 6. I got 6 x's here. Alright? And then how many do I have on the denominator? I got 3. 1, 2, 3. Alright? Is that making sense? I hope so. So check this out. I can go ahead and start cross-canceling things out. I mean, not really cross-canceling, but canceling things out. So what's x divided by x? Well, it's 1, so that can cancel out. What's x divided by x? Well, it's 1, so that can cancel itself out. What's x divided by x? Well, it's, yeah, that's right, it's 1, so I can cancel that out. So I'm left with 3 x's. And so how would I write that? Well, I can write it as x cubed over 1, which is really equal to x cubed. All right, I hope that's making sense. Now, I don't know if your teacher has ever talked to you about the idea that a base, like let's say 5 to the 0 power is equal to 1. Or if you have like 1,916 to the 0 power, that's equal to 1. And you might be like, why? And your teacher just says, because. So leave me alone. But no, that's not the real answer to it. So check this out. I'll explain why this is. And I'm going to do it with variables in a sec. So let's say if I had, I don't know, like x to the 4th dividing x to the 4th. Oh, I should have explained this further. Another way, I'm going to like scooch back a bit. So just hold off. I'm going to give you the gold to that 0 power exponent in a second. But check this out. Another way I can do this when I'm dividing, I keep the same base. We talked about that. And what I'm really doing is, if you notice, I'm doing a 6 minus 3. And what is 6 minus 3? Well, it's 3. So I get x to the 3rd power. Oh my gosh, that is the same answer. Okay? So this is the expanded form version. This is the simplified version. Okay? All right? And you don't have to write it out as 6 minus 3 in your exponents. That might look a little trippy. So, but the idea is, this is the process that you're doing. Why am I subtracting? Because I think I showed it out that those kind of cancel out from each other. All right, now, if I was talking about if I had x to the 4th power over x to the 4th power. Now, first of all, what does it mean when you have both the numerator and the denominator the same? When you have numerators and denominators the same, like if I have 1 over 1 or 7 over 7, these are all equal to 1, okay? Because when you divide it in, it equals the same. So x to the 4th over x to the 4th does equal 1, right? Because I could divide them in, and it's going to be the same. It's going to be 1, okay? But check this out. What if I was going to follow the pattern that I just showed you, where I'm going x to the 4th minus 4, okay? Because here we did 6 minus 3, that gave us 3. Here I'm doing 4 minus 4, that gives me x to the 0. So what we see here is that a base with an exponent of 0 is equal to 1. All right? So it really is equal to 1. And that's why that we get this, we have the value of anything to the 0 power is equal to 1, okay? Of real numbers. So, anything else? I guess the only other thing is that if I were to look at, I don't think I want to go into negative exponents. I'll wait for that for the next video. So I'll show you a little more of that in a moment. But thanks so much, and I hope this was helpful. Peace!